Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. So I hope I am perfectly audible and visible to each and everyone present over here. Hi Deepta, good evening. Welcome to the session. So in the last few sessions, we have successfully completed our chapter Carbon and its Compounds. So today we are going to discuss about 20 questions from the chapter Carbon and its Compounds. I hope all of you are ready for that. Okay, fine. So what we have discussed in the concept class about the carbon and its compounds. First, we have seen about the versatile nature of carbon, right? Then we have discussed about the hybridization, isomerism, IUPAC nomenclature of carbon compounds. In the last part, we have discussed about the chemical properties of carbon and its compounds, right? Yes, in the last session, it was about the ethanol and ethanoic acid, right? So based on those concepts, I am going to discuss some questions here. Let us start our first question. So this is our first question. Try to understand the question. Which of the following is an alkane? Hi Arush, good evening. So this is our first question. Which of the following is an alkane? The options are given here: ethane, propane, ethine and benzene. Arush, are you sure? Yes, Arush is giving me the answer as ethine and Deepta is giving me answer as propane. Let's see what is our answer. Yes, option B, propine is our answer. Propane, right? Propane. So from the question itself, we can get the answer, right? This is alkane. The suffix is ane. So we can identify the options from the ane suffix, which means propane will be our correct answer. Is that clear, Arush? Now let us go with our second question. So here is our second question. What is the general formula for alkynes? So in the hydrocarbons part, we have discussed about the classification of hydrocarbons, right? Saturated and unsaturated hydrocarbons. Among them, we have been discussed into alkenes, alkenes and alkynes, right? In that part, I have already discussed about the general formula for alkenes, alkenes and alkynes. Arish, what was our question? We need to identify the alkane, right? Not about the correct appropriate answer. So you need to answer according to the question. I think Aish was giving me the answer for the previous question. So what about this question? What is the general formula for alkynes? Option A, right? Okay, Ayush is giving me the option A. What about others? Deepta, Ayush. I am repeating, it is asking about the alkynes. Okay, many of you are giving me the answer as option A, but our correct answer is answer C. CnH2n minus 2. I hope I have discussed in the concept class about the general formula of alkenes, alkenes and alkynes, right? I will write it again here. If it is alkenes, what do you mean by alkenes? It will be the single bonds, right? Saturated hydrocarbons. For alkenes, the general formula will be CnH2n plus 2, right? CnH2n plus 2. So if you are asking about the alkenes, double bonded compounds, right? Alkenes, double bonded compounds or saturated hydrocarbons, it will be having the formula of CnH2n. Now the last case, unsaturated hydrocarbon is the alkynes in which triple bond is present in between the carbon atoms, right? So their general formula will be CnH2n minus 2. Clear? So what will be our answer? Option C will be our correct answer. So you need to focus on the general formula of alkenes, alkenes and alkenes separately. Okay, I hope you understand now. Here is our third question. What is the IUPAC name for C2H4? This is the main important part in the case of carbon and its compound. That is the nomenclature according to the IUPAC. What is the IUPAC name for C2H4? Condensed formula is given here. Yes, Arush. AN, ENE and YNE is the approach. AN means single bond compounds, alkanes. ENE means double bond compounds, alkenes, and YNE means triple bond compounds, alkyne. So what about this question? C2H4. Try to write out the structural formula of these compounds and find out whether it is an alkene or alkyne or alcohol. So option B is our correct answer, that is ethene. So how to write down the structure of this compound from the condensed formula? C2H4, right? C2H4, this is 2 carbon compound, and it is obtained that C2H4 means it will be CnH2n formula, right? If you are taking n is equal to 2, H will be 4, which means it is the formula of alkene, which means there will be double bond in between carbon atoms. Are you getting my point? Yes. So we need to balance those valencies of carbon by taking other 4 hydrogen atoms. So this will be the structure of C2H4 molecule, and the name will be ethene. 2 carbon compound, word root will be eth, and for double bond it will be ENE. So ethene will be the name of this compound. Clear? Hi AM, I don't know your exact name. So is that clear? The question is clear or not? Now we are moving to our next question. The question is based on the hybridization part which we have discussed in the first class of the carbon compounds. The assertion is given as sp hybridized molecules exhibit a linear geometry. And the reason is given as in sp hybridization, one s orbital mixes with the one p orbital to form 2 sp hybrid orbitals. Two equivalent sp hybrid orbitals. CnH2n plus 2, right? CnH2n plus 2 or CnH2n will be the general formula of alkenes, alkynes or alkanes. So here it is a general formula. This is a condensed formula and this is a structural formula. So what will be our answer for this question? Yes, both are correct, right? Which means both A and R are true, and R is the correct explanation of A. Option A will be our correct answer. So whenever we are discussing about the hybridization part, we have seen like that whenever 2 atomic orbitals of the same energy combine together, they will form new hybridized orbital, right? So in the case of sp hybridization, one s and one p orbital combine to form 2 sp hybridized orbital, and their geometry will be linear. Clear? So both A and R are correct, and there the R is the correct explanation of A. So option A will be our correct answer. Now we are moving to our next question. This is one basic question about the functional group. What is the functional group of alcohols? We have repeatedly discussed in the concept classes about the alcohols. So what is the functional group present in the case of alcohols? Okay, many of you are giving me the answer as option C. Yes, option C, OH, hydroxy group is the functional group present in the case of alcohols, right? Yes, option C is the correct answer. Then what about these functional groups, CHO? Yes, it is aldehyde, right? Yes, it is aldehyde. What about the case of COOH? It will be carboxylic acid, right? Carboxylic acid. And the last one, NH2. Which functional group it is? NH2. If you are writing like this, these single line have a meaning of one bond, right? So whenever we are combining a alcohol molecule, OH is combined with the carbon. So this has a particular meaning. So if you are putting OH minus like this, I mean OH like this, which means that there will be possibility of one bond after OH, which is not possible in the general case. Clear, Arush? So this one is correct. Clear? So this NH2 group is known as the amine group, not amide. Amide can be represented as CONH2. Clear, Deepta? Clear? Okay, fine. Now we are moving to our next question. What is the IUPAC name for CH3OH? CH3OH. Functional group is given here, OH. What will be the IUPAC name? Okay, Arush, I think you need to give more focus on this particular chapter. So once you are getting idea about the table, right, nomenclature word root for the table, then only you will get the idea of nomenclature, idea of naming the compounds, right? So here CH3OH, right, functional group is OH. So as we already know, OH is the functional group for the alcohol. So suffix will be OL. And here one carbon compound, what will be the word root? It will be methane, right? It will be methane, so it will be methanol. Or otherwise it is also known as methyl alcohol. So according to our option, it will be option A. Clear? Now we are moving to our next question. What is the IUPAC name for CH3CHO, aldehyde group? Options are given here: methanol, ethanol and propanol. Give me your answer first. CH3CHO. Yes, option B is our correct answer, that is ethanol. So CHO means aldehyde group, right? Aldehyde is having the suffix of Al. Then here it is 2 carbon compound. What will be the word root? It will be ethane, right? So it will be ethanol. Or it is also known as acetic acid. Sorry, acetaldehyde, right? Acetaldehyde. This is the common name of this compound, CH3CHO, and ethanol will be the IUPAC name of this compound. So option B will be our correct answer. Is that clear? In the case of IUPAC, the aldehydes can be given the suffix as Al only, not about complete aldehyde, right? Al will be the suffix for the aldehyde groups. So it will be ethanol only, not ethanaldehyde. Deepta, is that clear now? Now we are moving to our next question. What is the functional group of esters? What is the functional group of esters? Option C, right? C double O. So option C will be our correct answer. This is the functional group present in the case of esters. And the remaining we have already discussed: carboxylic acid, aldehyde and alcohol respectively. Now, here is our next question. What is the IUPAC name for CH3COOH? So what will be the answer for these questions? CH3COOH. What is the IUPAC name of this compound? First focus on the functional group. Identify the suffix for the functional group given here. Then find out the number of carbon. Then you will get the word root for that, right? So that you will get the IUPAC name of this particular compound. Okay, let us see what is our answer. So option B is our correct answer, that is ethanoic acid. So this is the functional group of carboxylic acid, right? For the carboxylic acid, the suffix will be oic acid, right? Oic acid. Then in the case of this particular compound, the carbon which is present in the COOH group is also considered as the total number of carbon, right? So here it will be 1, 2. 2 carbon compound means word root will be eth or it is ethanoic acid. Clear? This will be ethanoic acid, not methanoic acid. Methanoic acid means it must contain only one carbon atom. According to our IUPAC rule, we need to find out the maximum number of carbon atoms. We need to find out the longest chain, right? So here in the case of CH3COH, it's not only about the carboxylic acid. In the case of aldehyde as well as ketone also, we will be considering the carbon group which is present in the functional group. Deepta, do you understand now? So this will be ethanoic acid, or the common name will be acetic acid. Option B will be our correct answer. Okay, now we are moving to our next question. Again, assertion reason type question. Read the question carefully. Assertion is given as alkanes are also known as saturated hydrocarbons. And the reason is given as alkanes contain only single bonds between carbon atoms. Read the question carefully. Yes, formic acid and methanoic acid are same. Methanoic acid is the IUPAC name of the formic acid, which must contain only one carbon atom. Let us discuss after this question. So what is the answer for this question? Okay, Ayush is giving me the answer as option A. Let us see what is the answer. Yes, option A is the correct answer. Both A and R are true, right? So we have already classified the hydrocarbons into saturated and unsaturated hydrocarbons, right? Whenever they are having only single bonds, they are known as the saturated hydrocarbons, and the common case is alkanes. So alkanes are the saturated hydrocarbons, and these contain only single bonds between the carbon atoms. So both assertion and reason are true, and reason is the correct explanation of A, which means option A will be our correct answer. Clear? Deepta, what is your doubt here? How it will be wrong? So option A will be our correct answer, right? Yes. Okay, Deepta, now you will get the answer for the question. Match the following compounds with their IUPAC names. Options are given here: CH3OH, CH3CHO, HCOH, CH3COOH. And the second column is given the IUPAC names: ethanol, methanoic acid, methanol, and ethanoic acid. So what will be the answer for this question? Try to match the column with their name as well as the formula. So option A will be our correct answer. So let's see. CH3OH, right? CH3OH means functional group is alcohol. So we can consider here it is only one alcohol, that is methanol. And there is a CH3OH, only one carbon atom is present. So the word root will be methane. So it will be methanol. 1, 4, 3. Then CH3CHO, 2 carbon compound, and its aldehyde suffix will be Al. So it will be ethanol. So 2 for 1. Third one, HCOH, right? HCOH is known as the methanoic acid or formic acid. So what you're observing here, there is only one carbon atom is present here in the case of HCOH, which is a part of carboxylic acid. So it will be methanoic acid or the formic acid itself. So 3, 2 will be the combination. Then the remaining 4 will be 4, right? CH3COH is our ethanoic acid, which means option A will be our correct answer. Is that clear? HCOH is the, methanoic acid is the IUPAC name, and formic acid is the common name of this acid. Okay, I hope you understand. Now we are moving to our next question. Which pair of compounds belongs to the same homologous series? Which pair of compounds belongs to the homologous series, same homologous series? So what will be the answer for this question? It will be option C, right? As we already know, any of the series of compounds which have the difference between a CH2 molecule. CH2 molecule is known as the homologous series, right? So here if you are comparing the propane and butane, propane means 3 carbon compound alkene, right? 3 carbon compound alkene, CH3, CH2, CH3. And in the case of butane, it will be CH3, CH2, CH2, CH3, right? So what is the difference in between butane and propane? Only the difference of one CH2 molecule, right? One CH2 molecule is excess here in the case of butane. So such type of series of elements having the difference of CH2 molecule is known as the homologous series. Clear? Here is our next question. What is the general formula for esters? What is the general formula for esters? As we already know the functional group present in the case of esters. So what will be their general formula? Yes, option C will be our correct answer, RCO R dash, which means R and R dash are different alkyl groups present here. So the functional group present in the case of esters will be C double bond OO. Then the general formula will be RCOO dash, which means option C will be our correct answer. Arush, is that clear now? COOH is our carboxylic acid and it is our aldehyde, and this OH is our alcohol. Okay, here is our next question. Which of the following is used as a flavoring agent and has a fruity smell? Read the question carefully. Which of the following is used as a flavoring agent and has a fruity smell? Arush, again you need to get revision for this chapter. Try to watch all the recorded sessions for this chapter. I think I have completed 7 lectures for this particular chapter. So try to watch and make your own note by watching those sessions. And in that part, IUPAC naming is very important, and isomerism part is also very important. When you are getting the basic idea about that, it will be easy for you to get the idea about the organic chemistry, which is in the grade 11 and 12. So option C is our correct answer, that is esters. So whenever we are discussing about the esterification process, right, ethanol and ethanoic acid combine to form the ethyl ethanoate as a ester, right? Those esters are having the fruity smell, and it is act as a agent in the case of perfume preparation, right? Perfume preparation. So option C will be our correct answer. Esters have the fruity smell with the help in the production of perfumes. Clear? Okay, this question is very important. How to write down the structure of a compound from their IUPAC name? Which of the following compounds is named as 3-methylhexane? So what will be the answer? 3-methylhexane. So option A is our correct answer. So first we need to focus on the longest chain from the root word. It is hex. Hex means 6 carbon compound. So it will be 1, 2, 3, 4, 5 and 6 carbon. Right? It is A-N-E compound, which means they contain only single bonds, right? Single bonds in between the carbons. So it will be 1, 2, 3, 4, 5, 6. Yes, 5 single bonds in between the carbon atoms. Next, 3-methyl, it is a prefix, right? This prefix stands for the substituent in the case of compound, which means that in the third carbon compound, there is a branch of methyl group, right? So if I am writing the numbering from here, 1, 2, 3, 4, 5 and 6, right? 4, 5 and 6. Third branch, in the case of third carbon, there will be one branch of methyl group. Methyl group can be represented as CH3, right? So branch is already done and the longest chain is also done. Now we need to focus on the remaining hydrogens. So CH3, CH, clear? Is that clear? Did you get the point? First, we need to focus on the longest chain with the carbon number. That is hex here, which means 6 carbon compound will be the longest chain. Then ANE stands for only single bonds are present here, right? Then the 3-methyl stands for the substituent, or the third position of the carbon, 1 methyl group is present. That is the carbon here, right? Clear? So this will be the structure of this compound. CH3, CH2, CH. Okay. In order to satisfy these balances, this will be 1, 2, 3 and 4. So CH3, CH2, CH, CH3, CH2, CH2, CH3. That will be the compound representing the 3-methyl hexane. Is that clear? Is that clear? Is there any doubt? This IUPAC nomenclature is very important. Deepta, I didn't get you a question. What is your question? In the case of third carbon, I am adding a CH3 group. This CH3 group is known as a methyl group. It's not a carboxyl group. Okay, this chapter is little bit difficult as compared to all other 3 chapters, right? That is like very theory only. Here it is, we need to focus some important new points, right? That's why it's really very difficult, but it is not that much difficult. When you are practicing more, practice makes you perfect. Here is our next question. Again, assertion reason. Assertion is given as the suffix used for naming an aldehyde is Al. And the reason is given as butanone is a carbon compound having the functional group of CO. Read the question carefully, identify whether the assertion and reason is true and if it is the correct explanation or not. Read the options also carefully. So let us see what is the answer. B is our correct answer. Both A and R are correct, right? Both A and R are correct. But it is not the correct explanation of A. So what do you mean by the first assertion here? The suffix used for naming an aldehyde. As we have already seen in the previous questions, right? In the case of aldehyde, the suffix will be Al. Then in the case of butanone, ONE is a suffix, which means it is a ketone compound, right? It is a ketone compound. And in the case of ketone compound, the functional group will be CO or C double bond O, right? So both the assertion and reason are correct, but they are not the correct explanation. So how we can explain this first assertion here? We can take it as butanol is a carbon compound and having the functional group of CHO. Then it will be correct. Did you got? Okay, fine. Again, the naming of compound. The IUPAC name of the compound CH2 double bond CH3 twice is. Read the question carefully. Don't get confused with this part here. Try to write down the expanded structural formula of this compound. Then you will get the idea of IUPAC naming here. Arush, I need the complete answer, not the incomplete answer. Options are already given here. Yes, 3-methyl 1-butene, right? 3-methyl 1-butene. So that will be our correct answer, option B. So how we can write down this expanded structure for this compound? I will try to write down here. It will be CH2, right? CH2 double bond CH, again CH, then 2 CH3, right? It will be 1 CH3 here and the other one will be in the branched structure. Then only the valency of carbon will be satisfied as 4. So this will be the expanded structure formula of this compound. Now we need to do the naming here, right? What we need to do first, according to IUPAC, we need to find out the longest chain carbon compound. What is the longest chain here? 1, 2, 3, 4, right? 4 carbon compound. So I will start numbering from here. One, 2, 3 and 4. This will be the numbering, right? So what you're observing here, in the third carbon, there is a branch of methyl group, right? CH3 or methyl group. Then in the case of first carbon, there is a double bond. Double bond can be represented as ENA, right? Double bond can be represented as ENA. So what will be the name of this compound? First, we need to do the substituent name, right? Prefix will be substituent name here. So first we need to do the prefix here as the substituent. It will be 3-methyl. 3-methyl. Then word root, 4-carbon compound. Word root will be but, right? But. And the position of this ene group will be 1. So it will be 3-methyl 1-butene, or it can be either represented as 3-methyl but 1-ene. Both are same. Here it is understood that double bond is present in the first carbon and the methyl group is present in the third carbon. Is that clear? Is that clear? Then in order to write down the IUPAC nomenclature, you should give hyphen, right? You should give hyphen between the numbers and the words. It's very important. Now we are moving to the next question. The number of carbon atoms in the organic compound named as 2,2-dimethyl propane. 2,2-dimethyl propane. Try to find out the structure for this compound, then identify the total number of carbon atoms. It is asking about the total number of carbon atoms. In the case of IUPAC name, that hyphen stands for just like a separation, not about the bonds. Two dimethyl propane. I am repeating again, we need to identify the total number of carbon atoms in the compound. Dipta, it is prop, not pro. Prop for 3 and but for 4. So option B is our correct answer, which means 5. I know that you will make mistakes here. So first we need to write down the structural formula of this compound, right? Propane means it is the longest chain here. It is the longest chain here, right? So it will be a 3-carbon compound. I will explain. 3-carbon compound, CCC, right? And ANE stands for single bond. So there is a single bonds in between the carbon atoms. Then what you are observing here is 2,2-dimethyl, which means that in the second carbon there will be 2 methyl groups are present. Clear? 2 methyl groups are present in the case of second carbon. So if I am doing the numbering from here, 1, 2, 3. The second carbon there will be 2 methyl groups, that is stands for 2,2-dimethyl propane, right? Now we need to balance the valency here. It will be CH3. It is already balanced, it is CH3. So this will be the structural formula of this compound. So what will be the total number of carbon atoms here? What will be the total number of carbon atoms here? Five, right? 1, 2, 3 in the longest chain and 2 substituents in the methyl group. So total 5 number of carbon atoms are present in the case of this organic compound. Okay, I hope you understand. Yes. Here is our next question. Again the naming. Which of the following is the correct name of compound? CH3CH, CH3, CH2OH. Try to write down the expanded structure formula of this compound. Then identify the IUPAC name. So what will be the answer? Yes, option B will be our correct answer, right? 2-methyl propanol. So here it is. If you are doing the naming, right? If you are doing the naming, we can see that Whenever you have the functional group as OH, you should give the numbering for this OH group as least number. So I will be starting from here only. 1, 2 and 3. Right? This will be the structure of this compound, expanded structure, CH, and CH3 will be branched here. This is a substituent, right? And CH2OH. So if you are having the functional group as alcohol, we need to give the number for that carbon, which is the least number, right? It's least number. So I'm starting the numbering from here, 1, 2 and 3. So what you're observing here, it is 1, 2, 3. 3 carbon compound is propanol with the 2 methyl is the branch, right? 2 methyl propanol will be the correct answer for this question. Is that clear? Is that clear? So that's all about the questions today. I hope you understand the questions. Do you have any doubt in any part of the carbon compounds, carbon and its compounds? IUPAC nomenclature is very important. You need to identify the name of the compound from the structure. Similarly, you need to identify the structure of the compound from the name. And the isomerism part is also very important. Then ethanoic acid and ethanol part, their chemical properties and reactions is also very important. The next class, I mean tomorrow at the same time, I will be coming back with the more important questions from the same chapter, including hybridization and isomerism. Yes, in next class also we have the same practice session. I will be discussing more good questions. Okay, before that, you should be aware that you should be completely studied about the carbon and its compound chapter. Especially Arush, you have some difficulties in this chapter, no? So you need to focus more on the nomenclature part. Okay, I hope you guys enjoyed the session. If you really like the session, hit the like button, share this session to your friends also, and subscribe our channel, Infinity Learn 9 and 10 YouTube channel. Then if you want to get our session PDF, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. Then you will get the session PDF after all the classes here. Okay, I think we can wind up the session for today. Thank you so much all of you. See you in the next class. Be ready for the next